Okay. If you've made changes to a data block and a function, and you need to download those data blocks, I recommend not downloading data blocks while a machine is running, because it puts default values into the memory, so it can make the machine behave a bit unpredictable. But if you know it's fine, then hold down the control button and click DB1, and then click FC2. They're the two that I want to download first. Sorry, they're the two that I need to download. I want to download my DBs first. That's why I've clicked that first. I hit download. It's going to ask me, DB1 already exists, do you want to override it? And I'll just go all. So I override DB1 and then FC2. What happens if I don't do that? If I say actual speed integer, so my actual speed is byte 6 of DB1, save that, and then in my code I insert a new network, and I'm going to divide an integer of motor dB actual speed, so I'm going to scale it depending on what units the actual speed comes back in, and I'm going to write it to somewhere else. Memory word 20, just for a spot for now. So I'm going to save that. Might just highlight first that if I go to my hardware manager, go online, my PLC is healthy. It's all good, no errors. My last thing was going from startup to run. Close that. Now I'm going to download this function because I want to do the scaling. Yes. Let's go online and have a look. And we'll see that there's no green and I'm in stop mode. What happened? So I've stopped the PLC, so if it's a safety PLC, it's going to cause an e-stop. Everything's going to come to a screaming halt. Let's go to the hardware configuration and see what happened. So at this point we're in a good state. Sorry, at this point we're in a good state, and here we've got an error. So error length, error in reading, access address 6, OB 121. So it's a bit cryptic. It tells us the address that we're trying to access, 6, which is that 6 there, but it doesn't actually tell us it's DB1, so you've got to do some hunting to find that. And then it failed to write to that memory. Because it failed, it called an interrupt. The interrupt is OB121, and the stop was actually caused by OB121 not being loaded. This is in FC2, so a workaround we can do is if we go offline and we create a new organizational block 121 program error. So if we open this up, there's no code in there, but this block gets called whenever there is a program error. So you can put timestamps or set up any sort of code in here that you want to call, like a normal interrupt. So let's just download that to the PLC. The PLC is still in stop mode, so let's just restart it. warm restart, and we're in run. So we're running, but we've still got errors. So the machine's going to keep running now, but our code doesn't make any sense. This is when your large buffer comes in handy. It's already full. The last 500 events are area length, so access address 6. So we're getting a fault here, so we'll get rid of that. And that's because we haven't actually downloaded this to the PLC. db1.dbw6 does not exist. Before we added this, 4 was the largest number. So if we download this to the PLC, yes, my error light has now gone off the PLC, and we now don't have any errors. It's a bit hard to tell that there's no errors here, so if you can, I like to go to operating mode, stop the PLC, start the PLC again, and come back in here, and you should have the last diagnostic being start up to run. So we're all good. I'll show you how we can make changes without causing the PLC to error. So I'll go online, and I'm just going to remove OB121 from online, so if it does have an error, it will stop the PLC and we'll know that there is an error. So DB1, let's add actual torque, and it's integer and 0. Save that. We don't download that yet because we're going to break it, and I'm just going to copy this whole network and paste it and change this to actual torque. Torque's got to give different scaling, and we're going to store that here. We can also give these quick names, so memory word 22, edit symbols, remote torque, and now we've got a name for it. So hopefully, I want to download both these changes to the PLC without causing any issues. So I want to download the DB and the FC, and I want to download. I want to overwrite all of them, yes, and our PLC is still fine and running because I've clicked DB first and FC first and then download. It's, do you want to override the DB1? Yes. So it's downloaded DB1, that's done. It's created the memory for that torque, and now it's going to download the FC that tries to address that memory for that torque variable. So you want to make sure that you have the memory there first before you have the program trying to access that memory.
Why did you delete?
So I deleted OB1 because it will make it very clear if it tried to access the invalid memory. So if OB1 was in there, and say for 1 or 2 cycles it tried to access memory that wasn't there, it wouldn't stop the PLC, it would give an error, but as soon as the memory was there, it would work fine. So just sort of proving that it was accessing valid memory all the time. Generally you will want to have OB1 in your program, so we'll download that again, and there's a few other ones that are common. 80 cycle fault, I can't remember what they are, CPU fault, module error, power supply fault. So each of these are predefined. Generally, you should add most of them, and if you get a CPU that goes into fault, it'll tell you what OB is not loaded. Create an empty OB and just download it. So we'll download all those. Yes. So I can't download OB84 or 81, so they must not work on this actual PLC. So we'll get rid of those. So those are the only ones that are valid for this PLC.